So here are some limits, guys. We can do all these without a calculator. We should have experience with all these limits here. So I don't think we should have any issues. This one is direct substitution. And we can just, and how do I know a direct substitution? Because I don't get a 0 on the bottom. So 2 minus 4 is -2. And then 2 squared is 4. Plus another 2, that's 6. Plus another 2, that's 8. So I get -2/8, which is the same thing as -1/4. This one here, I can't do direct substitution because if I plug in a 3, I get a 0 in the denominator. But you also get a 0 in the numerator, so that should be a big hint. It's an indeterminate form, and you guys don't know L'Hopital's rule yet, so you're going to have to do it with algebra. So doing it with algebra, I'm going to write the word limit because I haven't evaluated anything yet. As x approaches 3, and then that's the difference of squares. All this is over, and then factor this out. So that's going to be x minus 3, x plus 2, because 3 times 2 is 6, and -3 plus 2 is -1. Now that I have it like that, the x minus 3's cancel out. And now that the x minus 3's cancel out, now I can do direct substitution. 3 plus 3 is 6. 3 plus 2 is 5. And there it is, 6/5. This one here, there's nothing you can do about it, guys. X equals 2 is the VA. Because I have a vertical asymptote of this function there, this you can either say does not exist. The behavior of your approach from the right is positive infinity. The behavior of your approach from the left is negative infinity. So this is the best answer in there. Letter D is the same as letter C. The only difference is it's being squared. Because of that, oh, what's up? Someone had a question?
Yeah, I don't understand C. Is it because it doesn't equal out to 0 over 0?
Correct. If it doesn't have 0 over 0, then that means you have a number divided by 0, which means you definitely 100% have a vertical asymptote.
Okay.
If you were to graph it, I guess I should do a better job. So if you were to graph it, you do have a horizontal asymptote of 1. It would look like this, though.
How do you know there was a horizontal asymptote?
Oh, because I have an x on the top and I have an x on the bottom. So as x approaches infinity, it's just 1 divided by 1.
Oh, okay.
You see that? And then letter D is similar to letter C, guys. I still have a vertical asymptote at 2, but this time my horizontal asymptote is 0. And this one looks something like this. That one looks something like that. Actually, no. At -3. This one looks something like this. There we go. Something like that. Okay. Yes, you can say it does not exist. But this time, the behavior of the approach 2 from the right and the approach 2 from the left is positive infinity. So you could say it does not exist or positive infinity. Personally, I think the behavior is the better answer, but does not exist is an appropriate answer, and I will show you some AP questions later on. Sorry for you YouTube fans, I have to edit out those AP questions because College Board will not allow me to print those out on YouTube. So don't give me a thumbs down because I delete that. So yeah, what's up?
Without graphing, how do you know that it approaches positive or negative infinity?
I know that I approach positive infinity because I have a square in the bottom. So if I approach 2 from the left-hand side, it'll never be negative. It'll just be a really, really small positive number.
Okay.
You see what I mean there or no?
Yeah.
Okay. So don't just say okay. Just I'm gonna say it again because I know not everyone caught it. I know that it approaches positive infinity from both directions because I have a square in the bottom. So no matter what, as you approach 2 from the left and the right, the x minus 2 is just going to get smaller and smaller and smaller. If I approach from the left, you're going to get smaller and smaller, but negative. Negative 0.1, negative 0.01, negative 0.001. Chavez, I have no idea what you're talking about. I'm talking about like if x is 1.9. 1.9 minus 2 is negative 0.1. 1.99 minus 2 is negative 0.01. 1.999 minus 2 is negative 0.001. And because you're squaring it, that negative turns to a positive. It's still going to be a small number. Remember, if you have a number between 0 and 1 and you square it or raise it to any power, it just gets even smaller. So you're still dividing by a small number. So that's how we know that it's approaching positive infinity. All right,
So,
guys. Oh, what's up? Ask.
whenever you do direct substitution and then you get it a 0 only in the denominator, is that whenever the answer would be does not exist?
I don't want you to be a robot, but yes.
Okay. No, it just helps though.
Okay, all right. Just don't be a robot. But don't be mad at me, miss. I can visually see your face.
I'm not mad. I'm smiling.
Oh, okay, we're good. See, guys, we're good, Miss McLaren. Limit of x approaches infinity of 3x minus 5 over 2x plus 4. That's end behavior. That's just 3 over 2. I hope that we're kind of getting pretty good at those, guys. I hope that we can already see it. And there is some teachers out there and professors that they love to do divide by x, divide by x, divide by x, divide by x. And then they just cancel. They say like, oh, this approaches 0, that approaches 0. Those x's cancel and it's 3. Those x's cancel and it's 2. And you get 3 over 2. I don't like that route. But, you know, whatever floats your boat. I think Khan Academy does that. If you've been watching Khan Academy, they do that a lot. I don't like it. But, you know, it doesn't matter what I like. It matters what you like. I just look at end behavior, guys. Just look at the end behavior. I try not to be a robot. So this one, letter F, without doing that Khan Academy trick or whatever you want to call it, I look at it and I say, well, the denominator grows faster than the numerator because x is approaching infinity. So that means I have some number divided by an even bigger number. And since x is approaching infinity, that must mean that this is going to be approaching 0. See? All right, guys. And I think we can go through this one pretty quickly, I think. It says, given the graph y equals g of x below, evaluate the following limits. So we're just looking at graphs. Limit as x approaches infinity. It looks like, they should have put an arrow there. It looks like I'm approaching whatever this green line is, and that green line looks like it's what, -3?
I'm sorry, I didn't catch the previous problem. If you could scroll up real quick. Sorry.
You're talking about letter F?
Yes.
X, in the bottom, I have an x squared, and on the top, I have a 4x. X is approaching infinity, so you should be thinking end behavior. So because you're thinking end behavior.
Okay, thank you.
Oh, okay. Are we okay?
Yes, sorry. It's because I'm writing down the problems like as we go because I don't have a printer. But yeah.
No, you don't have to write anything down. You can just listen. I'm gonna post this on YouTube, miss. So you don't even have to worry about writing anything down. You know what? I'll forward you the whole video to you, and while I wait to upload it to YouTube and edit it. So we can do always do that.
Thank you.
All right, so here we go, guys. Letter A, limit as x approaches infinity. Put little arrows on these things. They should have been there. And then this goes down like that forever. That looks like going up, and going up. All right, so now it looks a lot better. There we go. Now we put arrows. Limit as x approaches infinity. It looks like it approaches this green line. It looks like -3. Let's go in alphabetical order. So I'm going to go to letter B. Limit as x approaches -infinity. So I'm looking at this one. If I'm approaching -infinity, that looks like it's approaching the x-axis, which is the y value of 0. Letter C, I'm approaching -3 from the left-hand side. So the x value of -3, here's -3. So the x value of -3 from the left, it's approaching positive infinity. You can also say it does not exist. They're both valid answers. Letter D, well, the better answer is infinity, by the way, because it's a behavior. Letter D, limit as x approaches -3 from the right-hand side. So here's -3 again, and I'm going from the right-hand side, and that one looks like -infinity, or does not exist. If they asked, they did not. But if we have letter D.2 for the second version of D, then, and they said limit as x approaches -3 of g of x, well, the behavior on one side is positive infinity, the behavior on the other side is -infinity. So the best answer for that one is does not exist, because I have two different behaviors. Oh, look, there is two D's, but I accidentally, man, E, F, G, H. All right, sorry about that, guys. Limit as x approaches 0 from the left. All right, I'm gonna approach 0 from the left. There's my whole. It looks like that y value is at 0, so put a 0. Limit as x approaches 0 from the right. So I'm approaching the x value of 0. It looks like my y value just keeps going up forever. So either positive infinity or does not exist. Which one's the better answer? Since I'm talking about a behavior, I think the positive infinity is a better answer on that one. Letter G, limit as x approaches 4 from the left. 4 from the left, it looks like positive infinity. Letter H, limit as x approaches 4 from the right. It looks like positive infinity, or does not exist, right, for both. There it is, guys. Cool or not cool?
Cool.
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 All right.
Cool.
Yay, let's go now. So these are supposed to be tougher ones, guys. I really honestly just took them from UH. I was looking at the questions you guys were getting wrong, and you guys are getting those wrong. So yeah, let's talk about them. Letter E and D. Letter E, I just stole that one from the textbook there. So letter A, you can't do direct substitution because you get 0 over 0. But notice that's an 8, and I see a cube there, so that's a hint. So the numerator is a sum of cubes. So if you forgot what sum of cubes looks like, it looks like this. So that's what I'm going to do. This is x times x times x. This is 2 times 2 times 2. So the b is a 2. So here we go. I'm going to write the word limit because I haven't evaluated anything. Limit as x approaches -2 of x plus 2, x squared minus 2x plus 2 squared is 4, all over x plus 2. Now that I have it written this way, I can cancel out those factors, and now I can do direct substitution. Let's see, -2 squared minus 2 times a -2 plus 4. So 4 plus 4 plus 4. 4, 8, 12. So the answer is 12. Yay. Another happy, satisfied individual, customer. You guys aren't customers. You guys are my people. But yeah, all right. Let's keep going, guys. This one here, I don't know. I really like this question. There's 2 different ways you can go about it or think about it. You can multiply by the conjugate, and you're saying, well, conjugate of what? Like, well, I guess you can do like the conjugate of the numerator there, and you can say it's multiplied by square root of x plus 2, and then hopefully you'll notice that it looks very similar to like the difference of squares. But that's a hint. That's what I want you guys to notice, that square root of x times square root of x is x. 2 times 2 is 4. So you can literally say this is the difference of squares. So I'm going to put equals, since I'm not evaluating it yet. I'm going to do that. Limit of x approaches 4. And you can't do direct substitution because if you plug in a 4, you get 0 over 0. So that's how you know it has a limit for sure. And then I'm just going to write square root of x minus 2. I'm going to leave that alone. And on the bottom, I'm going to write square root of x minus 2, square root of x plus 2. And now that you have that, you can delete the square root of x minus 2's. See, guys? So now I'm just going to write the word equals and put the answer. So equals, now I don't have to write the word limit anymore because I'm just going to put the answer. 1 over, because you have a 1 here, it's a fraction. And the square root of 4 is 2, and then 2 plus 2 is 4. So the answer is 1/4. How are we feeling, guys? Are we feeling okay?
Yeah.
All right. Look at letter C. Letter C, if you were to do direct substitution, the square root of 16 is 4. 4 minus 4 is 0. 0 divided by 0. OMG. As soon as you see 0 divided by 0, you know that you got a limit. You 100% know. And because you know that, you should reward yourself and go grab a slice of pizza or something. Not right now, though. Later on. So I'm going to write limit as x approaches 0. I know it has a limit. Like, man, what do I do? How do I solve this? Well, we're going to trick it. We're going to multiply by the conjugate of the numerator. And you're going to have something that resembles very similar to like a difference of squares. Chavez, I don't know what you're talking about, Chavez. That's supposed to be you guys. I did like a very bad interpretation there. All right. So what am I talking about when I say it looks like the difference of squares? Well, consider this a term. It's not. I mean, you have a whole bunch of stuff in there. But consider this a term. So this is like a minus 4. I'm just saying the square root of x plus 16 is a. And this is like a plus 4. OMG, look. This is the difference of squares. Well, it's a difference of squares if you multiply it, if you distribute it. A squared minus 16. So that's what I want you to say it again.
I thought when you multiplied by the conjugate, you did it like on top and bottom.
Oh yeah, you do. You do it on top and bottom. That's just an error on my part because it has to be a 1. I don't know why I did that. That is so funny. I hope I would have caught it eventually. That would have sucked. So look, guys, this is just a 1. The whole point of multiplying by the conjugate is because I want to multiply by 1. So you haven't changed anything. You're not going to do anything to the bottom. The top, you are going to do stuff to it. So here we go. Limit as h approaches 0. And the top now looks like this. X plus 16 minus 16. That's a 16 there with a giant parenthesis. All over. And on the bottom, I'm not going to bother distributing. X plus 16 plus 4. You can drop the parentheses like it's hot. Because, you know, when you hold something that's hot, you drop it, right? That's how Snoop Dogg got those lyrics, guys. He had some hot chocolate and he dropped it. It's like, oh, I dropped it because it was hot. And then it just blew up. So those 16s cancel out now. And now because those 16s cancel out, you just have an x in the numerator. And OMG, I can now cancel out those x's. And because we can cancel out those x's, now we can do direct substitution. Now that we can do direct substitution, I can just write the number now. 1 over, and then let's see, what do I have? 0. The square root of 0, the square root of 0 plus 16 is 4. 4 plus 4 is 8. So the answer is 1/8. Courtesy of Snoop Dogg. Cool or not cool, guys?
Cool. Cool.
Man, you guys sounded very excited there. Limit as x approaches 0 of absolute value of x over x. I don't know why I wrote it again. I guess I didn't need to. So hopefully by now you start to see I have some number divided by that same number. So the magnitude is always going to be 1. But if I'm talking about positive numbers, it's going to be a positive 1. So if I were to graph this, guys, it would be positive 1 like so. And then if you're talking about negative numbers, the magnitude is still 1. But the numerator is never going to be negative. See, so if you choose an x value like negative 10, you have absolute value of negative 10, which is 10, divided by negative 10. So you're going to get negative 1. So you look like this. There's only one location where you're undefined, and it's at 0. And it so happens to be that that's where they want the limit at. So this one does not exist. If they would have given me a side, like a plus on the upper right-hand corner, then it would have been 1. If they would have given me a minus, a 0 from the left-hand side, then it would have been negative 1. And then letter E here, it just looks hard, guys. It's not. So you can't do direct substitution because of this guy down here. You get a 0 there. So let's go ahead and expand it. Limit as x approaches 2, 3 to the power x plus sine of pi x. So sine of 2 pi, by the way, is 0, right? So hopefully you know that. Pi x. We're not solving yet, so I'm not plugging anything. X to the 4th plus x minus 2 over. And on the bottom, when we factor this out, you're going to have an x minus 2, x plus 1. I'll give you guys a few seconds to catch up. And then once you do that, the x minus 2's cancel out. And now that I have those x minus 2's canceled, I think I can do direct substitution now. So let's see. Limit as x approaches 2 of 3 to the power x plus sine pi x over x to the 4th plus 1 over x plus 1. Yes, I can do direct substitution without a problem. So we have 3 squared plus sine of 2 pi. And yes, I know sine of 2 pi is 0, but I just want to reiterate. Any chance I get a chance to do pre-cal again, we'll do a little bit of pre-cal. 2 to the power 4 plus 1 over 2 plus 1. And on the AP exam, you can actually leave it like that. And I will actually encourage you to leave it like that if you are prone to accidents. But if you are not prone to accidents, I'm going to say you keep going. But if I grade every single exam of yours and quiz and see that you are always making an algebra mistake, I will tell you directly on the little feedback I give you, leave your answer here. That way we can knock out that AP exam. And I don't do it because like I'm trying to be mean. I do it because I want you to pass that AP exam. Because you're always doing algebra errors. Not everyone. Just, well, not you guys, because you guys are pretty good. 3 squared is 9. Plus 0 over, let's see, 2 to the 4. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Plus 1/3. Oh, that's nasty. I guess if you want to get a number, we got to fix it, right? So let's go ahead and fix it. 9 over, and then 16 times 3, what's that? 16, 32, 42, 48. So 48 over 3 plus 1 over 3. So 9 over 49 over 3. Keep, change, flip. 9 times 3 is 27. 27 over 49. Man. Did you have to do all that? No. If this is an AP exam, you could leave it alone right there. If you are prone to accidents, leave it alone on the first step. If you are confident, keep going. How do we feel, guys? Can we take some more?
Yes.
Okay.
Wait, do we leave it with the 2 plugged in or with the X?
I don't see any X's anymore. I just see, like, what do you mean?
Like where the arrow is, that's where we would stop.
If you are prone to accidents, yes.
Okay.
Okay, so look at this right here. So this is coming from Delta Math because you can already tell the formatting of that picture there. So it says, use the graph of the function f of x shown to the left in order to determine this limit. So if I approach 6 from the left, if I approach 6 from the right of this function, so here's the value of 6, and I'm approaching from the right-hand side, so I got to follow this graph. And there it is. I'm approaching this specific y value. That y value is 3. And there it is, that's it. Man, I should have made this like a little, I probably should have made that picture a little smaller. Let's see what we have here. The function f is shown to the right. Determine the equations of all vertical and horizontal asymptotes of f and the equivalent limit equations. Okay, let's draw in the vertical asymptotes first. It looks like I have a vertical asymptote there. It looks like I have another vertical asymptote there. All right, now let's draw in our horizontal asymptotes. And it looks like it's this line here. And it looks like it is this line as well. All right, we're ready. So let's do the ones in red. So I'm color coding them. So it says, okay, I'm gonna write VA, x equals -1, and x equals 6. What else did it say? And the equivalent limit equations. Okay, so I'm gonna write, since at -1, they're both approaching positive infinity, I'm gonna say limit as x approaches -1 of this function equals positive infinity or does not exist. I do not remember what Delta Math accepts. I think it accepts D and E. So just look at the little notes on Delta Math and see what it says, see which one it takes when you get your assignment. And limit as x approaches, let's see, this one, again, from the right and from the left, it's approaching positive infinity. So it's safe to say this. And I'm gonna say positive infinity or DNE. I don't remember which one it accepts. I think there's a little symbol button that you push in there. All right, and then for the horizontal asymptotes, let me write those in blue. Limit as x approaches positive infinity of this function. Well, I'm looking at this one because that arrow is the one that's going to the right forever. That one is approaching the value of 4. And then limit as x approaches negative infinity of that same function. So now I'm looking at this line because it's approaching to the left there. And that looks like it's going -1. Oh, and horizontal asymptotes, right? Horizontal asymptotes, y equals 4 and y equals 1.
Isn't it -1?
-1. Man, what's wrong with me today? I wrote -1 down there, but I didn't put -1 up there. Silly. How do we feel, guys? Do we feel okay? Okay, let's keep going.
Yes.
Let's keep going. Oh, look, another composite function. Let's see. Let's see if we can do this. So a little while ago, I told you guys that that means limit. Oh, well, I guess I can write it like this. It assumes that f is continuous. And look, notice that f is not continuous there. F limit as x approaches -1 of g of x. And it's assuming that you're continuous at -1 or whatever this number is for f. And you are continuous in various locations, but you are discontinuous at several locations. So as long as it's not any of these numbers, as long as I don't get -6, as long as I don't get a 0, we'll be good. All right, so let's see. -1 for g, so here's -1 of g. That y value looks like 0. So this means f of 0. Well, f of 0, look at that. You have a jump. So this does not exist. Because you don't have, this must be continuous at 0. You cannot say 7. So do not say 7. Do not say 7.
What's the limit of both of those?
Does not exist.
No, like in like those type of equations, it's for the limit of f of x and g of x.
Yeah, the limit as x approaches -1 of f of g of x does not exist.
Okay, thank you.
Yeah, you have to be continuous at whatever numbers this spits out, guys. You have to be continuous. So if it would have said 2, I would have said -2. If it would have said 4, I would have said, well, the same. It looks like the same value. If it said 5, I would have said 0. All right, let's do some more. So don't worry, look, we got more practice. We got more practice right here.
Continuous just means that there's a point there and there's not a hole, right?
Correct, at that point on the curve. Limit, so let me write f of limit as x approaches 4 of g of x. That's what it means. So go, oh look, I accidentally put the g on the left and the f on the right. So go to x approaches 4 for g first. So here it is. It looks like that y value is 0. So now this means f of 0. And at 0, the graph of f is continuous. You're good. You're real good. So that's going to be a 2. So how do I rewrite it? Limit as x approaches 4 of f of g of x equals 2. And if you look at the notes for Delta Math, they might have some different type of notes than this. The way I'm showing you is the right way to do it. If you look at a university textbook, you'll see it this way. But Delta Math might do like the Common Core, the high school thing. But it should, maybe it'll be the same, maybe not. But I'm sure that the explanation will make sense. Are we okay with that, guys? You guys there?
Yes.
Okay.
Yes.
I thought maybe, okay. And then this is just properties, guys. You guys, I'm not trying to insult your intelligence. These are just properties. Remember from a long time ago now, limit as x approaches 1 of f of x. You can break this up times limit as x approaches -1 of g of x. You can break it up like that. So now you got to look at both because it wants a product. So limit as x approaches -1 of f of x is, you're not looking at the solid, you're looking for the limit. So it looks like -5 times limit as x approaches -1 of g of x, that looks like -4. So it looks like it's 20. So there it is, guys. So this answer here is just 20. Are we okay so far, guys?
Yes.